So it says here, according to the fundamental theorem of algebra, which polynomial function has exactly 8 roots? So let's look at let's look at our function. Let's look at number 1 here. So it's asking polynomial. It's asking the question's asking how many which function has 8 roots, right? So polynomial has 8 roots. So let's look at A here. A here states that f of x equals, this is 3x squared minus 4x minus 5 times, I need some more space here, times 2x to the power of 6 minus 5, okay. And then B here states that f of x equals 3x to the power of 4 plus 2x to the power of 4. C states that f of x equals I have 4x squared minus 7 to the power of 3. And finally, I have D here is f of x equals 6x to the power of 8 minus 4x to the power of 5 minus 1 times 3x squared minus 4. So I have four functions here. So let's look at the first function here. I have 3x squared times 3x squared minus 4x minus 5 times 2x to the power of 6 minus 5. So let me just expand this in terms of I could FOIL this, and I could expand this in terms of one long polynomial here. And if I were to expand this kind of function here, I would get 3x squared, or 3x squared, if I just do the first part of FOIL, it's 3x squared times 2x to the power of 6, right? So in this case, I would get 6x to the power of 8 is my first term if I multiply these two terms together. And I could do this with this one times this one times this one, and so on and so forth, right? But as you can see, my tall polynomial has a degree of 8, right? It's going to be my highest degree in this function here. So this here has 8 here, which is good because I want 8 roots, right? The second one, I have 3x to the power of 4 to the power of 4, right? So whenever I'm taking an exponent and I'm taking another exponent, I'm multiplying exponents. So my first term here would be whatever 3 to the power of 4 is, which is, let me use my calculator, 3 to the power of 4 would be 81, right? So this is 81 times x, and 4 times 4 here is 16, to the power of 16, right? So this here, obviously, it does not have 8 roots in my degrees. So the 16, it could have up to 16 roots. I don't really know how many, right? So that's not incorrect here. So B here is incorrect answer. C here, I have 4x squared minus 7 to the power of 3. I can take 4 cubed, and I would get 64. X squared times to the power of 3. Here's 2 times 3. Here is 6, right? Which is great. And this here just simply minus whatever 7 cubed is, right? 7 cubed is 343. 343, yeah. Okay, so that's good. That's okay. That my polynomial here in this case is 2 to the power of 2 to the power of 3 is 8. Actually, sorry, I don't know why I wrote 6 here. Oh no, this is 2 times 3. Sorry, 2 times 3 here is 6. So see here again, it's incorrect answer because it's actually the power of 6, so the degree here is 6, so it's not 8, right? So this here is also incorrect. And then finally, D 6x to the power of 8 times 3x squared here, I would get 18x to the power of 10, right? I'm adding these exponents. So in this case, you can have 10 roots, which is incorrect, which means A here has to be my logical answer because the highest degree here is 8. So let's look at the polynomial function. According to the fundamental theorem of algebra, a polynomial of degree n will have exactly n number of roots. It doesn't have to have exactly n number of roots. It's saying up to the n amount of roots, right? For example, a parabola could have 1 x-intercept, right? Or it could have 0 x-intercepts, or only imaginary roots, right? So it's not technically only only 2, right? It's not technically up to the number, so it's fine. So we expanded this, so you got 6 to the power of 8, which is what I had here. So exactly 8 roots, that's good. Second polynomial has 16, like we wrote before. This here is 81x to the power of 16. Third polynomial has 6, which is 64x to the power of 6. And finally, fourth polynomial is 18x to the power of 10, which is the power of 10 here. Hence, option A is correct. So this here is great solution and answer. And I'm going to correct his fundamental theorem of algebra. However, having nth degree polynomial does not mean that you have n roots. It means that you can have up to n roots from 0 to basically from 0 to n roots. So or also imaginary roots, right? Also imaginary roots, or I can say complex roots, which we do not account for. Okay, sweet. So solution here is correct.